The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, thank you for joining us today for our webinar discussing odor control in wastewater with our very own Darren Skutt, Technical Service Manager with CARUS Corporation. I am your moderator today. My name is Dylan Kemmer and I am our Lead Generation Specialist with CARUS Corporation. A few housekeeping items before we get started. All attendees are in listen-only mode to help cut down on any background noise. If you have any questions, we encourage that you submit those throughout the presentation using the question pane in the GoToWebinar panel or email us directly. If you submit your questions through the GoToWebinar, we will receive a report with the questions and your contact information to follow up directly after the webinar. If you are interested in receiving a PDF or a recording of the presentation, please contact us. We encourage you to share the recording within your network. Here are a few ways to find us. We have listed our website and general sales and marketing email address, as well as my email address. Do you receive our email blast for upcoming webinars, presentations, trade shows, and technical information on our various solutions? If not, sign up on our website. You can find the Join Our Email list on any landing page on the right-hand side. Be sure to select the industry when signing up to ensure you receive the most targeted information for all your needs. And we can't forget to mention our social media platforms. We encourage you to connect with our CARUS Corporations page, as well as our team members on LinkedIn, where we are often sharing upcoming events, including webinars, industry articles, or news, sharing relevant posts from other industry experts, and more. Follow up on our YouTube, Twitter, and Facebook pages as well. If interested in any upcoming webinars, here we list our webinar landing page, where you can find upcoming webinars, registration information, as well as our on-demand webinars recorded previously and available for you at your convenience. At this time, I would like to take this opportunity to introduce our speaker, Mr. Darren Skutt. Darren has worked for CARUS Corporation for 20 years, and the last 5 years as the Technical Service Manager. As the Technical Service Manager, Darren conducts laboratory testing and product demonstrations for CARUS Corporation's municipal, industrial, and environmental customers and prospective new customers. These product demonstrations include technical training, safety presentations, and installation of safe chemical handling and dosing systems. He is a graduate of Illinois Wesleyan University in Bloomington, Illinois, with a bachelor's degree in chemistry with ACS certification. Mr. Skutt is a member of AWWA, Water Environmental Federation, and the American Chemical Society.
Thank you. So we're going to talk today about odor control in both municipal wastewater, so both in the collection system and in the wastewater treatment plant itself. A brief outline of what we're going to cover is a little bit about how the collection systems are put together and where the different treatment applications would be in a wastewater treatment plant, how you would go about doing an odor survey, what are your treatment options, and then case studies for many of these application points. So one of the things we want to talk about at the beginning of this presentation is what would be the causes of odors, how are they formed, why are you looking at treating them, and then what are some of the things that you can do to treat the odor that you may have and the complaints that it's generating around your process. Over the years at CARUS, we've had many questions coming from different customers about different areas in their wastewater system and where they could have odor complaints. Especially anytime it's near the public. Some of the places that we have worked with over the years would be collection systems, and that would include pump stations, force mains, and gravity sewers. We've also worked at the wastewater treatment plant, and that has been both at the headworks, sometimes in the clarifiers, and then also in the sludge dewatering, so belt presses and centrifuges. Typically, the complaints that we get are generally for nuisance odors. They're getting customer complaints from the area about hydrogen sulfide and mercaptans are causing odor complaints, and people are calling in saying that the area stinks around the wastewater plant or around the force main or gravity sewer. They're getting complaints from the neighborhood. Sometimes they're also concerned about worker safety because they have a high level of hydrogen sulfide, and so they're applying the product to remove the hydrogen sulfide for that worker safety issue. Other times it can be that they see a lot of equipment corrosion. They flip open the manhole, or they have a lot of corrosion on the equipment at a pump station, and it's from hydrogen sulfide destroying those pieces of equipment, and they want to protect that equipment and stop that from happening. One of the last applications is sometimes out in the collection system they have issues with grease removal, and one of the applications that we'll talk about later as a case study will be grease removal in a collection system. So when we talk about odors in a wastewater system, there can be a lot of different odors that you can smell. Depending on what type of compound it is, whether it's a mercaptan or hydrogen sulfide, they'll have distinctly different smells. In the case of some of them, something like skunk would be organic gases that contain sulfur compounds. Sometimes they may be rotten cabbage, which are also organic sulfur compounds. It may be fishy, that may have a nitrogen compound. We sometimes get customers that are using lime treatment on their sludge, and they complain about having an ammonia smell from the additional lime. It could be something like the decayed flesh or fecal, which will be different types of compounds as well. Depending on the type of odor compound that they're specifically looking at, they can have a very, very low odor threshold. So it can be well below parts per million, even into parts per billion levels, where you can actually still smell these odor compounds. What you see here are the list of different mercaptan compounds that have different smells, and then the odor threshold where a human will be able to smell them above that level. Some of these things are used to our benefit. Mercaptans are used to give a smell to natural gas so that you can smell it when there's a leak. But in the case of a wastewater plant, if you have a mercaptan, it's going to cause an odor complaint in the area. Typically, when we talk about it, you have those mercaptans, but the major odors that you'll see in a wastewater system are typically starting at the top of this list. Hydrogen sulfide by far is the most common odor complaint that you'll see, and typically the one that you'll see at the highest levels in both the collection system and in the wastewater treatment plant itself. Depending on what type of treatment they're doing, you may see ammonia. A lot of times that's part of the process. They're either trying to remove ammonia or they're adding lime for treatment in the process and it's generating ammonia. There are several other gases that you'll see depending on what type of processing they're doing in the plant. You could see carbon monoxide, carbon dioxide. If they're doing some type of digestion, they may have some methane generation where they may have a methane flare at their plant, and then oxygen and nitrogen. So, as I mentioned, by far the largest compound that we see in wastewater typically is hydrogen sulfide. It's a colorless gas. It does have a very distinctive rotten egg odor. One of the things with hydrogen sulfide is it's both water soluble, so it'll be in the wastewater itself, and then any kind of turbulence will strip it out of solution, and then you'll have the gas in the air that you can smell. It's considered extremely toxic, which you'll see on the next slide. It's very corrosive, and it can be explosive. It's one of the things when people do safety checks on confined space entry, hydrogen sulfide is one of the things on the 4 gas monitors that you'll use. The other thing with hydrogen sulfide is that rotten egg odor actually over time will deaden your sense of smell. So if you're in an environment with a lot of hydrogen sulfide, you'll initially smell that rotten egg odor, and then the longer you stay in that environment, the rotten egg odor will go away, making you think the odor has gone away, but the hydrogen sulfide will still be there. If you leave the area, typically your sense of smell will return in 15 minutes, 30 minutes, and you'll start to notice the smell if you go back into the area, but it'll deaden your sense of smell if you continue to be in the area for a long time. So in a lot of cases with hydrogen sulfide, you'll have monitors to monitor the levels just so that you're not fooled by what your nose is telling you. Specifically on hydrogen sulfide, OSHA sets limits around the safety involved with it. Currently, the OSHA limit is a 10 ppm max for a time-weighted average if you're in that area. As you can see on this graph, as little as 0.1 to 0.2 parts per million can generate an odor that can generate a complaint. As you get closer to 10, you might experience some headaches and nausea as you're in the area. And then obviously as the level gets higher, it can be immediate life threat at higher levels. Every year, you'll occasionally hear in newspaper articles and online of news stories where people went either into a sanitary sewer or they were working in an area where there was hydrogen sulfide, and there are deaths related to being exposed to the hydrogen sulfide at really, really high levels. So it's definitely something that you don't want to take lightly. and definitely continue to monitor the situation when you're in those areas where you think you might have hydrogen sulfide, and if you are treating, continue to monitor it to make sure you've treated it to the level that you need to. So how does hydrogen sulfide form both in the collection system and in the wastewater plant? Typically, the formation involves the use of sulfate. So wastewater will contain large levels of sulfate plus other organic material. And then anaerobic bacteria, because they don't have the presence of oxygen, will start chewing the oxygen off the sulfate molecule. And while they do that, they'll generate dissolved sulfide in the wastewater itself. As that dissolved sulfide level increases in the wastewater, eventually a portion of that dissolved sulfide will go atmospheric as hydrogen sulfide, and any type of turbulence, or if the temperature get warmer, some of that gas will leak out of the wastewater and you'll have hydrogen sulfide in the atmosphere. These sulfate-reducing anaerobic bacteria thrive at low oxidation reduction potentials. So anytime you lose your low dissolved oxygen in the system or the wastewater sits and all the dissolved oxygen goes away, these sulfate-reducing bacteria will start to breed and start to generate more and more dissolved sulfide in solution. Typically in wastewater, we're between pH 6 and 9, and that's where they thrive. And they also like the warmer water temperatures of wastewater. So it's a perfect environment for these sulfate-reducing anaerobic bacteria to grow and generate hydrogen sulfide in the wastewater. When we look at a picture of a collection system, specifically what we're looking at here is a force main or a gravity sewer out there in the distribution system. So you'll have the pipe wall itself, and then typically what you'll have is a slime layer of the sulfate-reducing anaerobic bacteria that grow on the wall of the pipe itself, and then the wastewater is slowly passing through that pipe as it goes to the wastewater plant. What happens is the longer and longer that wastewater sits in the collection system, the dissolved oxygen in the wastewater will go down as it's chewed up by the aerobic bacteria. Eventually you'll run out of dissolved oxygen, and at that point in time, the sulfate-reducing bacteria will start using sulfate as a source of oxygen and start stripping the oxygen off of the sulfate and producing dissolved sulfide in the wastewater. Over time, as that layer, that dissolved sulfide builds in the wastewater, eventually you'll get to a point where some of that dissolved sulfide will strip out of the wastewater itself, and so you'll have both dissolved sulfide in the wastewater and atmospheric hydrogen sulfide in the headspace above the wastewater itself, typically in the crown of the pipe. So when we talk about hydrogen sulfide, there is a little bit of an equilibrium that we look at. Typical, like I said, in wastewater, typical pHs are in the 6 to 9 range for wastewater. And generally, as you can see on this graph, that if you're in the pH range of 6 to 9, you're going to have a portion that's going to be dissolved, and you're going to have a portion that's going to be atmospheric hydrogen sulfide. As you raise the pH up and get above pH 9, you're going to trap most of the sulfide in solution as dissolved sulfide, and you won't have as much atmospheric at that point. This is one of the things that pH adjustment is used for, is to trap the sulfide in the wastewater itself rather than let it go atmospheric. The one thing to keep in mind, if you trap the dissolved sulfide in solution with a higher pH, at the next opportunity for the pH to drop down below 9 into the 7 to 8 range, anything that was trapped in solution as the pH lowers will then be off-gassed into atmospheric hydrogen sulfide. So there is a risk if you're using pH adjustment that as that pH drops back down as you combine with other flows, that you would strip some back out as the pH drops back down to a more normal level for wastewater. One of the questions that comes up sometimes is we don't get too many complaints in the cold winter months versus the hot summer months in regards to hydrogen sulfide odor complaints. There's two reasons that happens. One, obviously, where we're at in the Midwest, in the cold winter weather with heavy snows, people don't go out as much and aren't as exposed as much to different parts of the collection system out there in the treatment system. The other thing is, as the temperature rises, more and more dissolved sulfide will strip out of solution. What this graph is illustrating is, depending on what the dissolved sulfide level is in the wastewater and then what the temperature of the wastewater is how much atmospheric hydrogen sulfide that you would get from that. If you look at the bottom of the graph, at a half a part of dissolved sulfide, that'll typically give you somewhere between 0 and 100 parts per million of atmospheric hydrogen sulfide at a normal pH. As you increase to 2 to 4 to 6 milligrams per liter dissolved sulfide, what you can see, the temperature starts to have a dramatic effect on how much strips out of solution, and you'll have much higher levels in the atmosphere based on those warmer temperatures. So looking at the graph for 2 milligrams per liter, you can see that it starts down around 100, but gets up around 750, just changing the temperature from 0 to 40 degrees. So you will strip more at these warmer temperatures. When we talk about the oxidation of sulfide with permanganate products, permanganate will oxidize sulfate across a range of pHs. It doesn't matter which pH we're at, whether it's acidic, neutral, or basic. The one thing that does change is how much permanganate that we need per part of dissolved sulfide when we do these reactions. A typical rule of thumb that we use at CARUS is somewhere between 2 and 4 milligrams per liter of permanganate per part of dissolved sulfide, as long as you're in the pH 6 to 8 range, which is pretty typical for wastewater. One of the benefits of using permanganate in wastewater for odor control, especially for hydrogen sulfide, is our reaction rate. Our reaction rate between the dissolved sulfide and the permanganate when added to solution or added to sludge will be instantaneous. We'll knock the odor down immediately. So in most applications, we can be at the application point where they're generating odor. We just need to go a few seconds upstream, say 10, 15, 30 seconds, apply our permanganate, and we'll knock the odor down completely in that much time. Some of the other products that you may see out in the field, like peroxide and iron salts, do require some reaction time to remove the sulfide from the issue. In the case of peroxide, they'll talk a lot of times about 15 to 30 minutes of contact time to remove hydrogen sulfide to 0. In the case of iron salts, it's a precipitation reaction, and so you do need some contact time to precipitate the dissolved sulfide and prevent it from going atmospheric. What that means in these cases is you'll have to go farther upstream to apply these chemicals to get the removal of the hydrogen sulfide in the dissolved form prior to your release point. The same thing is true in the case of mercaptan destruction as well. In this case, we're looking at different chemical compounds and looking at compared to mercaptan destruction. In the case of permanganate, our dosage is much lower for removal of mercaptan in a wastewater. You can see our dosage is all the way down to 177 parts. In the case of peroxide or iron salts, you can see much higher dosages at 420 and 1456 to remove the mercaptans from this wastewater. So we also gain the benefit and the use of permanganate in the case of certain mercaptans in wastewater, that we remove them at a faster rate and we can remove them to a lower level quicker by applying less permanganate than other typical odor compounds that you would see used for odor control. One of the things that we talk about with our customers, especially if they call us and they have an odor complaint, is what we want to do is systematically collect information about the wastewater system itself. So where is the odor complaint coming from? Is it specifically just around one manhole or one lift station in the collection system? Or if it's in the wastewater plant, is it around a clarifier? Is it around a dewatering process, whether it be a centrifuge or a belt press? Where are they generating the majority of their odor, and where are the majority of their odor complaints coming from? Once we have that data, we can then look at the flow rates. So how much of the wastewater or sludge that we're treating? Are we seeing different type of odor compounds, whether it be hydrogen sulfide or mercaptans, and what levels are we seeing in those areas? And what we'll do with that data is walk through where is the best application point, where is most of the odor release happening, and then how much chemical do we need to apply to knock it down in those cases. Once you have all that data and organize it, you can make a plan of action for what you're going to do for your treatment. Typically when we do this odor survey, we'll do a couple different things to determine what we're looking at as far as odor complaints. One of the first things we typically do, because hydrogen sulfide tends to be the largest odor complaint out there in municipal wastewater, is we'll use ODOLOGs or other type of online sensors to collect data over time. We can put one of these monitors in and collect data for a week or a day and look at trends to see if it's a certain time of day in the collection system when the pump station is more active that's generating, or is it just a general odor over the course of a full day. In addition, we'll also do air sampling with Mercaptan tubes to determine if there are mercaptans in the area. And then we'll also look at the wastewater itself, and we'll use different types of dissolved kits, whether it be dissolved sulfide to determine how much sulfide is in the wastewater itself. We may also use other test kits to test what product we're using to determine do we have enough of our chemical in the wastewater itself, specifically in the case of a nitrate product, to determine that we have control, we have excess nitrate in the collection system to provide that odor control itself. But these are all tools that we use to determine what would be the best course of action for odor treatment. When we're out in the wastewater collection system, basically what we want to get an idea of is where is the odor complaint, and then backtrack from where the odor complaint is to see what's upstream of it. So is there a lift station upstream where there's the ability to put equipment in? Are we at a manhole that's a gravity sewer discharge and we don't have any facilities where we can put any equipment? What all is upstream? So maybe at the point we're at, there's multiple lift stations that feed into the same feed line and only one of them has an issue. So as we collect that data, what we'll look at is what's feeding into the source where the odor is, what's upstream of it, and then we'll also look downstream to see, hey, does ours feed into another point where maybe there's not odor complaints, but it's causing damage to the equipment downstream because it's stripping the sulfide out of solution and causing odor complaints, but no one's there to smell them, but it's damaging the equipment. We'll also get all the way to the headworks of the plant. Are we seeing issues at the headworks with the wastewater coming in? Are they having odor complaints there? Specifically, when we talk about corrosion in the collection system, what we're worried about is both the odor complaints and then also the unseen damage below the ground that you can't see in the pipe itself. In the picture you see here, you have wastewater and then hydrogen sulfide in the atmosphere above the wastewater, and you can see that it's attacking and corroding the pipe in the picture. What does that look like in the actual collection system? Over the years, we've had sections of pipes where customers have done replacement in the wastewater system, and when they pull the pipe out, as you can see in the picture, the complete crown of the pipe is corroded away. Eventually, that pipe could collapse because there's nothing supporting the top part of the pipe. Typically, the other place you'll see it is everything looks okay. As you're walking down the street, you can smell the odor coming out of a manhole, but the manhole looks fine itself. You open the manhole up to get a sample of the wastewater itself or to put a sulfide monitor in the manhole, and when you flip open the manhole, you can see all the corrosion on the concrete and on the metal below the manhole cover. This is a hallmark of hydrogen sulfide corrosion in a collection system. One of the things that we always do is when we flip open a manhole and see corrosion like this, and we're going to hang a monitor, we always check to make sure the rungs are stable and they won't pull out of the wall, or that the thing's not going to crumble and we're going to lose our sulfide monitor because of how much corrosion's gone in to the concrete itself. There are some simple things you can do in your wastewater collection system to help prevent the formation of hydrogen sulfide. A couple of the things that you want to keep in mind is keep the wastewater moving from the far points of the collection system to the wastewater plant. So have adequate flow velocities which move the wastewater itself and any solids that are in the wastewater through those pipes to the wastewater plant as quickly as possible. So what we'll talk about with a customer is minimizing the detention time in the system. Obviously, you don't want the wastewater to sit at a lift station for very long. The longer it sits, the more likely you are to generate hydrogen sulfide odor complaints. So if they can pump the wastewater more quickly downstream and minimize that detention time, that'll minimize their complaints. Another thing that they can keep in mind when they look at these lift stations and pump stations is just good housekeeping. If they're seeing a lot of grease, like you see in the picture there that's building on one side, they can either use treatment to remove it or they can vacuum that grease out. One of the other things that we talk about customers with, it's always a good idea to have a good pre-treatment program and tell people in the area, both homeowners and businesses, about grease traps and cleaning their grease traps, and then homeowners about not dumping grease down the sewer where it can cause impacts to the pump stations and lift stations and to the collection system itself. Basically, all these things, having good housekeeping, not dumping a lot of grease down the drain, minimizing detention times, keeping the flow velocities up, will maintain dissolved oxygen and prevent the odor issues that you would normally see in a collection system. So when we talk about collection system treatment, there are a lot of options that we have here at CARUS Corporation. And what they really depend on is what your application point is, what your flow rate is, and then what type of reaction rate you're looking at. So specifically when we talk about collection system treatment, we generally talk about stuff like CAIROX CR potassium permanganate tablets. We'll talk about TOTALOX odor eliminator, and then we'll talk mainly about CARUSOL liquid permanganate. But basically this graph gives you an idea of what would be the recommended first choice for one of our products. Some other things that might not necessarily be the first choice, but might be a better fit for your specific application, and things that you would not use in those types of applications. Specifically, when we're looking at the collection system treatment, that would mainly be gravity sewer manhole, lift station, and headworks. So all the stuff that's out in the collection system to the very front part of the process. As I said, specifically what we're going to talk about here in collection system treatment for odor control will be CARUSOL liquid permanganate, TOTALOX odor eliminator, CAIROX CR potassium permanganate tablets, and you could use CARUSOL plus liquid permanganate. Pictured are our tablets, and then all three of our solutions that are liquid, TOTALOX, CARUSOL, and CARUSOL plus, will look like the dark purple solution you see in the middle picture. The first product that we're going to talk about is CARUSOL liquid permanganate. It's available in two concentrations, both 20% and 40%, and it's available in drums, IBCs, and bulk. The solubility of the third product that you see to the right means we can supply it as both a 20 and 40% solution, and it can be fed neat directly into the wastewater at your application point. Our first case study is a collection system lift station. And specifically, this lift station was treating about 1.2 million a gallon days of a flow rate. They were getting a lot of odor complaints from a rotten egg smell from the neighborhood, and there was a recently built soccer park nearby where there was a lot of soccer tournaments being held. They were also, as you can see in the picture, having some grease issues in the wet well itself. They were building over on the corner where the pumps and the floats were in the wet well. So what they chose to do was they decided to put a data logger in the wet well to collect baseline hydrogen sulfide data. What we found was we had an average of 14 ppm in the wet well itself and occasional peaks of 80 ppm coming out of the wet well itself. What they were looking at was they wanted to treat specifically at this lift station itself. Everything upstream of this lift station was all gravity sewer that then pulled into this lift station itself. There wasn't an upstream lift station. What they were doing currently was, just for the grease issue, was they were cleaning the wet well every 6 weeks because of the grease buildup in the corner that was impacting the floats for the pumps. So what they chose to do, and using that sulfide data that we had from the data logger, they chose to use CARUSOL liquid permanganate at the pump station and stuff as the wastewater was moving toward the wet well itself. So basically treatment on site to immediately knock the odor down that was ending up in the wet well itself. Their usage was 5 gallons per day. And what we found from the data logger was, depending on different times of day, there was higher flow rates coming from the collection system coming to this lift station. So the initial system was 2 feed pumps on different timers to base the feed rate based on that varying flow rate. With treatment, the average hydrogen sulfide in the wet well dropped to 0, and we only saw occasional peaks of 10 ppm. The other thing that they kept track of was how often that they had to clean the wet wells of the grease issue. And one of the things that liquid permanganate will do is it will emulsify grease and make it easier to pump downstream. In the case of this situation, they went from every 6 weeks to only 3 times a year that they had to clean the grease out as it built up. The bigger win for the city was that they had no odor complaints from the neighbors and no odor complaints from people watching their kids play soccer in the park next door. The next product that we're going to talk about is also for collection systems, and it's TOTALOX Odor Eliminator. This product is a two-part product that has permanganate for immediate oxidation and then has a nitrate salt for inhibition of sulfate reduction. Typically, when we think of the bacteria out there in the collection system, they really want to chew on oxygen. Once they run out of oxygen, they'll chew on the oxygen off of a nitrate source, and then once they run out of nitrate, they'll chew on the sulfate itself and generate the dissolved sulfide. So in this case, if we've run out of oxygen and we give them a nitrate source, they won't generate the sulfide because they'll be using the oxygen off the nitrate source itself. Kind of some typical rules of thumb that we use at CARUS for TOTALOX Odor Eliminator is that we need approximately 2 to 4 gallons of this blended product per pound of sulfide to be removed in the wastewater. Generally, what we're doing with the TOTALOX product is we're feeding it upstream to maintain odor control through multiple lift stations or through multiple lift stations and gravity sewers. So we can feed this product at one point and maintain control through many different parts of the collection system. General rule of thumb that we use is we want 0 dissolved sulfide in the effluent downstream. So if we apply the TOTALOX upstream, what we want to see is no dissolved sulfide downstream because we want to make sure we're not generating any dissolved sulfide. And then depending on how far we're going to have odor control downstream, if we're near the application point, we might actually see some nitrate residual in the wet well itself. And as we try to maintain that nitrate residual, we may see it through multiple parts of the system and then see very little nitrate as we get farther and farther downstream where we're not having odor issues, or the wastewater is moving quickly enough that we're not generating any odor at that point. Some of the things that we keep in mind when we're applying the TOTALOX product to a collection system is that in warmer temperatures we may require higher dosages because the bacteria are more active. And then the other thing that's more important is generally we want to look at detention times in the collection system. So how long is the wastewater sitting in that force main? How long is that wastewater sitting at that lift station before it's pumped downstream? The longer those detention times we have, the more toward the higher of the 4 gallons from 2 to 4 that we'll be feeding. So for a collection system lift station case study, it was a southeastern county in the US that was responsible for a very large wastewater collection system, and they had many, many pumping stations throughout this collection system. Most of their pump stations didn't have any odor complaints or any odor issues. One lift station in particular was the Carus, of course, was generating a lot of odor complaints. And it actually had 2 things that were generating those odor complaints. The pump station itself was near a busy road, and then there was a grade school located on the adjacent property. Depending on which way the wind was blowing from this pump station, wind would blow toward people passing by on the highway, or at other times of day, if the wind was prevailing toward the school, it would blow toward the very front of the school, where people were dropping their kids off for school or picking them up at the end of the day. And obviously, you have parents waiting for their kids coming out of school, and anytime the wind blew in that direction, you would have odor complaints from the people sitting waiting in the parking lot for their kids. This highway lift station, that they called it, received wastewater from 2 main locations. The vast majority of the flow at this lift station was 100,000 gallons per day coming from a 12-inch diameter force main upstream. This smaller pump station was 3.4 miles away, and based on a normal day, the wastewater was typically sitting in this pipeline for at least 24 hours before it started to discharge at the highway lift station. There was also the school contributing, but it was only about 5,000 gallons a day when the school was in session. One of the things that we measured looking at the 2 different application points was where was the dissolved sulfide coming. In the wet well itself, we could actually grab samples that were specifically from the lift station upstream or from the school itself. What we found was there was no dissolved sulfide in the fresh wastewater coming from the school, and the vast majority of the odor was coming from the lift station upstream. So when we looked at that lift station upstream, what we found was there was about roughly 4 to 5 milligrams per liter of dissolved sulfide in the wastewater discharging into the highway lift station from that upstream lift station. One of the things that we wanted to look at was what was generating the odor complaints and how high were the levels. Atmospheric hydrogen sulfides with the lids closed on the lift station itself, we were seeing sometimes as high as 5 ppm leaving the vents or the holes in the lids themselves, and that was what was generating into the air and then drifting based on wind direction. Placing the odor log into the wet well itself, we saw levels typically as high as 50 ppm in the wet well itself. As you can see on the back of the truck, we parked on the road and did all that testing on site to determine what the odor levels were at the site. Based on wanting to control odor into this lift station, we decided to go upstream at the small upstream lift station. The initial dosage was 10 gallons per day of the TOTALOX odor eliminator, and we eventually increased that to 15 gallon per days when they would get occasional odor spikes based on us looking at that data logger data. With treatment, the dissolved sulfide levels at the highway lift station were less than 1 milligram per liter, and the atmospheric hydrogen sulfide dropped to less than 0 ppm coming from the vent, and we got it all the way down to less than 5 ppm in the wet well. Based on this 15 gallon per day treatment and the lower levels of hydrogen sulfide, they were generating no odor complaints at the school and no odor complaints from people passing by on the road, so the city considered it a success. So for our third application in the collection systems, we're going to look at our CAIROX CR potassium permanganate tablets. The tablets are a mixture of 80% solid potassium permanganate with other binders. They typically are about the size of a hockey puck, so 2 inches in diameter, about 3/4 of an inch thick. They're a controlled release product. What that means is you basically will place them in the wastewater flow in a mesh bag, and then over time these tablets will slowly dissolve and release the permanganate to the wastewater to provide odor control. We've done many field tests with the tablets for hydrogen sulfide odor control. These are designed for places where you are maybe in a downtown area where there's only manholes, or there's areas where you don't have lift station access. And the idea behind the tablets was a product that could be placed below the manhole, tied off, and everything is below grade, so nobody that's passing by would see any of the treatment system. Everything's below the manhole cover itself. In the case of these, what we would do is we would deploy the tablets in one manhole, as you see in the picture, and then just downstream at the next manhole, we would suspend a data logger to look at what type of odor control treatment that we had. In the case of this collection system in a downtown area, we had a flow rate of roughly about 100,000 gallons per day that was flowing through these manholes. The initial trial was we placed 10 pounds of CAIROX CR tablets into the mesh bag. And what we did is we kept track of the bag weight, so how much of the tablets dissolved over time, and then how much hydrogen sulfide was removed downstream at the next manhole. As you can see in the picture, the tablets are loaded into the mesh bag, and then with the rope, we lowered them into the wastewater flow itself, and then tied the rope off. And once we were done there, we could flip the manhole closed, and all the treatment is being done below the manhole cover itself. So as we did this treatment system, what we looked at was what was the typical odor levels that they would have in those manholes, and then with treatment, what kind of levels did we have. As you can see on this graph, the blue levels are untreated, so there was no permanganate being fed in the tablet form, and those were the levels that they were seeing come out of that manhole. You can see, peaks of 3 ppm, 4 ppm, 5 ppm. What we believe was happening was those odor complaints were coming from those peaks, and that was where it was generating the odor complaints in the system itself. The initial test, what we did was we put the 10 pounds in the mesh bag, and we hung most of the bag into the flow itself to get the highest dissolution rate. What we then did was raise the bag up to put less of it into the flow to try to get a dosage adjustment, and you can see on the orange graphs that the level came up. So then we readjusted the bag multiple times and got it to a point at the end where we had more weight in the bag, more weight in the mesh bag and more in the flow, and you can see toward the end of our time that we were looking at 70, 80, and 90 hours downstream, at the higher rate of the tablets being in the wastewater stream, we're able to knock out completely all the hydrogen sulfide coming out of that manhole itself. So one of the questions we get with the tablets is, because they're such a low-tech way to deal with odor complaint, is how much time frame or how often do you have to reduce the tablets? One of the things that we've looked at is how much turbulence there is at the site, and then how much gallon per day flow are you having at the site. If you have a really low flow with not a whole lot of turbulence, so somewhere between 50,000 gallons per day and less, the tablets will typically last about 12 days before you have to replenish them. As you start to increase the flow rate, which obviously increased flow rate means more water flowing over the tablet, which means more of the tablet dissolves, you typically can get about 9 days out of the tablets. And then if you have a much higher flow rate, you might get as little as 6 days out of the tablets. Basically, what you'll do in this situation is based on your flow rate, how much turbulence you have, and whether you're taking care of your odor complaints or not, you can then adjust that bag up or down in the wastewater flow itself to get more dissolved tablets or less dissolved tablets. So that kind of covers the broad overview of the collection system and kind of 3 different applications for odor control and grease removal in the collection system itself. As we move downstream to the municipal wastewater treatment plant itself, there are a couple places where we may see some odor issues in the wastewater plant itself. Sometimes you may have some odor issues at the headworks. That may be an issue where you have generating some odor complaints. Typically, you may have some odor complaints in clarifiers in the treatment process in the plant. And then definitely downstream, as you concentrate the wastewater and have sludge, especially if it's primary sludge, you can have a lot of odor issues there, and then that'll be your dewatering process. Whether it be centrifuges or gravity belt thickeners or belt presses, you can have odor issues downstream at that application point as well. So when we talk about application points in the wastewater treatment plant, we're typically talking about the headworks, the clarifiers, the gravity belt thickeners, and then what your dewatering process is, whether it's belt press or centrifuge. As you can see, we have that same chart that we showed you earlier, and typically, depending on what part of the process you are in the wastewater plant, there are different products you can use. As you move toward the dewatering process, CARUSOL and CARUSOL Plus are mainly the products that you'll see used. So when we talk about that, specifically what we're going to look at is both CARUSOL liquid permanganate and CARUSOL Plus liquid permanganate in 2 different case studies in the wastewater treatment plant itself. You do have an option in clarifiers because it may just be a spot treatment. Say a clarifier has gone septic and is generating some odor issues, and it's generating odor issues today, but it doesn't generally do that. There's a case where you could use something like the CAIROX CR potassium permanganate tablets and either suspend them in the clarifier itself or throw some tablets in the clarifier itself. And then there's also an application for our CAIROX Nuggets potassium permanganate, which you see pictured on the far right of the screen with the ruler. And those can also be broadcast by hand over the top of a clarifier. They'll sink, and as they sink, the permanganate reacts and removes the odor in that type of application. Specifically, the 2 case studies that we're going to talk about in the wastewater plant. The first one was the wastewater treatment plant headworks. There was a concern at this plant specifically about worker safety at this small wastewater plant, and the plant generally received residential wastewater at a flow rate of about 0.95 mgd. The first process at this plant was what they called a 32,000 gallon flow equalization tank. So all the wastewater came into this tank, and then from there it went to coarse screening and grit removal. Because of the location of the equalization tank and because of some of the stripping of the sulfide, it was causing odor complaints in the area where this equalization tank was. One of the things that the plant staff had to do was occasionally they would have to go in to look at the coarse screening and grit removal rakes, and sometimes they would have to manually clean the screens because the automatic process wasn't working as well as it should have. Sometimes when they would go into that area, they would have their sulfide monitor on, and they would see levels in the building itself as high as 40 to 100 ppm, which you know is above the 10 ppm that's the OSHA standard. So what the manager wanted to do was he wanted to get the sulfides below the OSHA standard of 10 ppm, and he really wanted a target of less than 5 ppm, which would allow the workers to be in the building for longer periods of time to work on the grit screening and removal if they had issues with that part of the equipment. So what they chose was they fed CARUSOL liquid permanganate, and they injected it into the collected wastewater just before it entered the equalization basin. What the goal of this study was to knock the odor down as quickly as possible. So we started at a very high dosage of 100 milligrams per liter. What we noticed was after we started this dosage of 100 milligrams per liter, within 2 hours, the level in the room on the data loggers dropped from 20 to 25 ppm to 5. What we then did was we lowered the permanganate dosage down to 50 milligrams per liter, and we still saw the atmospheric sulfide drop down to about a steady 2 to 3 ppm. We then eventually lowered the level to 25 milligrams per liter, and we're still maintaining that 2 to 3 ppm of atmospheric sulfide in the room itself. So we were below the goal of 5 ppm, and we were only feeding 25 ppm. That initial high dosage was because we had a lot of odor built up in the room, and basically we just needed the air to turn over and the wastewater to turn over that had been treated to finally get to a more normal level. The next application we're going to talk about is CARUSOL Plus liquid permanganate. This is available as a 20% solution, and it's available in IBCs and bulk, and it has the same purple color that you see as the CARUSOL liquid permanganate. Our application was at a wastewater treatment plant belt press, and what they were doing was they were treating 150 gallons per minute of wastewater, and the wastewater was primary solids and was typically around 3 to 4% solids. Their current treatment, they had no treatment for the application, and they were generating odor complaints in the room around the belt press itself. What they decided to do was look at CARUSOL Plus for odor control in the same room as the belt press. The application point was prior to polymer addition, but we were in the same room about 20 feet away from the polymer addition. Permanganate was injected directly into the sludge line and then went up to the polymer injection point, which was just prior to the belt press, and then the sludge went out onto the belt press itself. During the course of the trial, what we did was we looked at very many different dosages of the CARUSOL Plus liquid permanganate, and then what type of odor do we have at the different treatment levels. With the CARUSOL Plus at 100 milligrams per liter, we were able to knock the odor down to below 100 ppm, and this was directly on the application point where the sludge was pouring out onto the top of the belt press. If we were then take that odor log and walk farther back from the belt press just to be in the general room, we were seeing 0 ppm. So we then decided to lower the dosage to see where the odor would go to. So we lowered the dosage to 75 milligrams per liter, and you can see there's an immediate response where the odor immediately jumped up from below 100 to between 200 and 300. We lowered the dosage again to 50 milligrams per liter, and it jumped up between 400 and 500. And then we finally turned the permanganate off itself, and you could see that without any treatment, the sludge was generating somewhere between 500 and 600 ppm coming off the top of the belt press. So with that data, we also collected with the operators at the wastewater plant was what was the dissolved sulfide in the filtrate coming off the belt press, and then what the average and the peaks were. With no treatment, we were seeing the average dissolved sulfide be about 4 milligrams per liter in the filtrate that was underneath the belt press. And in like typical most wastewater plants, the filtrate that was coming off the belt press gets recycled back to the headworks of the plant. So one of the things that they noticed sometimes here was if they had a really bad odor day at the belt press itself, that filtrate was then discharging back up to the headworks, and it could sometimes cause odor complaints up there because of its high level. Atmospheric hydrogen sulfide without treatment, average about 569 with peaks of 640. With CARUSOL Plus treatment, As you can see the varying levels, we were able to knock it down. At the target dosage that we decided on at the end of the day from this case study was at 100 milligrams per liter, the average dissolved sulfide in the filtrate itself dropped to 0. The atmospheric sulfide directly above the sludge discharge on the top of the belt press dropped to 64, and the peak only got as high as 100 above the press. In the room itself, with the same data logger, we were getting 1 ppm or less at all times at the higher dosages. As we lowered that dosage to 75 and 50, the number started to creep up in the belt press room itself. So what they chose to do with this application was 100 parts of CARUSOL Plus for odor control to knock the odor complaints down in the belt press area. So in summary, one of the things you want to keep in mind when you're looking at a municipal wastewater system and you're looking at odor complaints is locate where those sources of odors are. So are they located around a certain part of your treatment process? If it's out in the collection system, is it a lift station? Is it a force main? Is it the headworks? Where are you generating your most odor complaints? And then what's upstream and downstream of those application points? Basically, get an idea of where you can feed, where you need to have your odor control at, and how far downstream do you need odor control. Some of the things that we always talk about with our customers is, as we look at those collection systems, is how do you minimize your detention time? Are there things they can do that don't involve the addition of the chemical that may help improve their odor complaints or eliminate some of their odor complaints in the system? So we talk about minimizing the detention time, moving the wastewater. We talk about good housekeeping in the system, kind of some things that the operators can do to make sure the wastewater moves downstream as quickly as possible. Once we have those things established, then what are the treatment options for permanganate treatment, and what are the application points? Typically, when we talk about these application points, as you saw in those two summary charts that show where our products would fit and where they would be at both in the wastewater process itself and what you're trying to treat for. In the case of CARUSOL liquid permanganate, if you have a really high odor issue, so high hydrogen sulfide levels or high mercaptan levels, and you really need to knock those down, you're going to focus on a product that's mostly permanganate. In this case, either 20 or 40% sodium permanganate. These applications typically will be in the collection system at a pump station. Because you have a liquid product, you're going to need a pump station where you can store the drum, or you're going to need a tank and a pump outside that are protected so that you can feed into that collection system. In the wastewater treatment plants, you typically, on sludge to water, will have high odor complaints, so you'll also use the 20 and 40% CARUSOL liquid permanganate. Another option in those applications is our CARUSOL Plus liquid permanganate. It will treat high odor levels, and you can use it both in the collection system and the wastewater treatment plant for the same type of odor issues you have. In the case of something like grease control, we would tend to use the CARUSOL liquid permanganate more than the CARUSOL Plus. If it was mainly just a hydrogen sulfide odor control issue, we would lean more toward the CARUSOL Plus product. For TOTALOX odor eliminator, that is going to be only in the collection system, and it's going to be times where you have long detention time. So the wastewater is sat for a long time, and you may want control through multiple lift stations or multiple gravity sewers, connected sites. And the TOTALOX will be fed at one lift station and then carry through those other lift stations to provide you odor control. Finally, in the collection system, if it's something like a manhole or a gravity sewer, you have no ability to put in a feed system or a drum or an IBC of chemical, you can use the CAIROX CR potassium permanganate tablets. And those are typically going to be lower odor levels. You just have a little bit of odor complaints coming out of that manhole. In the collection system, you have lower flows, and you have that, like I said, limited access. You can't put equipment in, so you need everything to be below the manhole itself. So in summary, you have a lot of treatment options with CARUS when you talk about odor control, and it's something that we look forward to working with you on.
All right, thank you, Darren, and thank you for everyone who attended and stuck around for the end. Just a reminder that this is recorded, so if you are interested, please contact me, and I can provide you with the link to the recording and a copy of the slides if you wish. If you have any questions, now is a great time to submit them. If you think of them later, feel free to contact us, and we can answer those for you. I have on the slide right now our contact information for our regional sales manager for your area. So if you're interested in contacting one of our regionals, you can call their number. And then also I have our general contact information. If you would like to contact us, there's through our website or through our general sales and marketing contact information. So I'll give a couple more seconds here for questions coming in. Okay, looks like we have a couple. The first one here, if I suspect I have an H2S issue, how would I go about checking the H2S level?
So the two typical ways would be some type of data logger. There's lots of ones out in the market, but you can basically place the data logger into the system and collect the data, whether you spot check or collect data over time. The other thing you'd want is some type of dissolved sulfide test kit, so you can measure that. If you think the odor's not Mercaptans, it's some of those other strange smells that I listed at the beginning, like skunk or cabbage, you could then specifically get a Mercaptan tube and try to test for that specifically.
The next question is, with the TOTALOX product, are you looking to carry a residual of nitrate throughout the whole system?
So with the TOTALOX product, typically what we're looking at is we want to carry nitrate residual through the control points. So if you're feeding at one lift station and there's maybe 2 or 3 lift stations downstream that you have odor issues at, and you want to have odor control through all those lift stations, what you would do is typically the one that's closest, you'll see a higher nitrate residual, and the next one downstream you'll see slightly less. And then generally what we try to target is at the last place where you want odor control is that you either have very little nitrate to none and very little to no dissolved sulfide. So there's basically a flex point right around no dissolved sulfide and no nitrate. So what we'll do is we'll adjust the feed rate, we'll measure nitrate and sulfide at that control point, and ideally what we want to do is try to target 0 of both. It's not always possible, so we'll default to the side of having just a little bit of nitrate at that point, but it's one of the things to keep track of. So you'll do a lot more dissolved phase testing with the nitrate than you would with just permanganate, because generally you're just looking at sulfide levels with the data logger.
All right, and then our last question, with your TOTALOX and CARUSOL Plus products, is there a different reaction time required than with your standard permanganate product?
Yes, there is. So when you look at those charts that list the different products and kind of the reaction rates, anytime you use anything that's focused more on the permanganate side, so our CARUSOL and our CARUSOL Plus are mostly focused on permanganate. Those are going to be immediate odor control. So as soon as you add them, they're going to react with the sulfide, remove it. So in those cases, you can be right at your application point or just barely upstream of your application point to knock the odor down. In the case of the TOTALOX product, if you have a lot of odor at that lift station and there's a lot of dissolved sulfide already there, the TOTALOX is mostly a nitrate-based product. There is a little bit of permanganate there, but the vast majority of the product is nitrate-based. What you'll generally do is go upstream because you need reaction time. The idea, what you're trying to do there is if you go upstream, is the nitrate becomes the food source so that you don't generate any of that sulfide as it travels downstream to that lift station where you have the odor issue. So in that case, you're almost always feeding way upstream at another lift station prior to where you're looking for your odor control with the TOTALOX. So that's where you'll do a lot more planning of what's connected in this system, what odor complaints are coming into this system, where's the wastewater coming from, and then you'll determine where's the best place to feed upstream with the TOTALOX. Okay.
Well, I'd like to thank Darren once again and thank everyone for attending today. Once again, a reminder, we will have a recording and the slides for this presentation available. If you would like to request them, contact us at the contact information below, and have a great day.